Hello AP friends! Today we're going to be talking about a really important section in our chapter 5, that is section 5.5. This one's a big one, folks. And this is often called U-Substitution. What we're going to be doing is going to be finding integrals using this new technique of U-Substitution. But, why? Well, let me harken you back to the last homework that you had to do where you had to underline inner functions. Let me pull that worksheet up. Here it is. So as part of your homework, you were looking through this and trying to find all the inner functions. And I asked you to underline what you thought were the inner functions. For example, on number 1, that would be the inner function because on the outside, there's another operation. Here it's being raised to the 5th. For number 2, hopefully you got that inner function, 3x minus 2. For number 3, 5x minus 2 is the inner function because on the outside is the square root. For number 4, 6x minus 1 is the inner function. Number 5. Number 6, all of these are inner functions. Number 7 is a little tough, but inside that cube root is a 2x squared minus 1. That's your inner function. If I keep going, number 8, inner function here would be the x to the 3 halves plus 2. And then finally for number 9, a little bit trickier, but the inner function here would be the x squared plus 4x minus 3. Now why are we finding this? Okay, do you remember the last time when we had to find inner functions and we talked about U-substitution? I'm going to go back to another worksheet. Hold on. Here we go. It was this worksheet. A long time ago, we had to find the inner functions here, and here, and here, and so on. But why? Why were we doing that? It's because we were finding derivatives using our brand new rule called the chain rule. And this was tough at first, although right now we're really good at it. But you remember at first, it was kind of tough. So we had to find u's so that we could substitute and make these derivatives easy to play with. So if this was our u here for number 1, this turned into u to the 4th. And then when you took the derivative of this, you used what was the chain rule? 4u to the 3rd, using power rule, times the derivative of u, which took us back to the original u that we underlined and found the derivative of that. So that's what we did way back when. So back to the other worksheet, back here, we're doing basically the same idea. But what U-substitution here is used for is to undo chain rule. We're going to be taking the integrals of chain rule and trying to undo them. So if you remember, off to the side, if I gave you a function that was a composite function, f of g of x, and I wanted you to find the derivative of this, we use basic chain rule. And the definition was the derivative of the outside, keep the inside the same, but we multiply the outside by the chain, and the chain was the derivative of the inside function. Okay, that's what regular chain rule was, but if we get rid of this here, now here's what your job is, guys. I'm going to give this to you, and you need to do this to it, and find the integral, find the antiderivative. And what that does, it should actually take us right back to the original composite function. The problem is, as you scroll around this page and you look at these integrals, they look really complicated. We cannot take the antiderivative of any of these by our normal means. So what we have to do is we have to try to make these integrals look a lot simpler so that I can rewrite it in terms of U-substitution and find the integral very easily. So I'm going to take a couple of numbers from this worksheet. What I would suggest you do is on a separate piece of paper, write down a couple of these numbers and we'll work on it together. Some of these steps that they put up here is actually pretty good. And I'll kind of bracket these. These are really good. Along with this video that I'm going to give you, I'll also give you my PowerPoint presentation. You can look through that. I'll send another YouTube video if you want that, and just a couple other slides just to help you through this, because this is as difficult and challenging and kind of as fun as learning the chain rule. And that took a little while, and this will take a little while too. So go ahead and get a clean piece of paper out, and we're going to start with number 1. But I need a clean page 2 because this is going to use up a little bit of space. Okay, hold on. All right, now I've got a fresh page, and here we go. So from that worksheet, I'm going to start with basically just number 1. And number 1 said, can we find the integral of x times x squared minus 1 to the 5th power dx? And dx always occurs inside the integral. All right, well, what we need to do first, because it's U-substitution, let's try to find what the inner function is. You found this already last time, but just to remind you, whatever's happening on the inside, that's having some kind of outside operation happening to it. So I would say that u is the inside x squared minus 1. Okay, and then normally we would rewrite this in terms of u and take the derivative, but we're doing the opposite today. We're trying to find the antiderivative. So we need to go a little further. So after you set up your u, let's take the derivative of both sides. Now that's du, the derivative of u, with respect to x. So this is du dx. All right, well, this is just regular derivative, power rule. I would just get 2x. Okay, so now I'm going to substitute my u back in, and I'm going to substitute my dx back in. But before I substitute the dx, it'd be really helpful if I could get the dx all by itself so I can substitute. So I think maybe what the best thing to do right now is let's try to solve this expression for dx. So I'll cross multiply and I'll do a little bit of algebra. You could try this on your own. But if I do this right, dx should be equal to du over 2x. Okay, that works well. If at any of this time, if any of these steps are going a little bit too fast, you can always pause the video, friends, and come back to it when you're ready. All right, I think I'm good to go. I've got my dx, and I've got my u. What I'm going to do is I'm going to substitute those back in. This goes in here, and this is going to go over here. Ready? Here we go. This becomes the integral of x times, not x squared minus 1, but now I've got my new fancy u. I'll write that as u to the 5th, because u was x squared minus 1. But I'm not going to write dx either. I'm going to substitute this in for my dx. This becomes du over 2x. This looks a little bit better, you gotta admit. But the problem is I still have x's and u's, and I really can't have two variables. I need to get only u's. So look and see what happens. Let's just simplify a little bit of algebra here inside the integral. And I've got an x and an x that divide and cancel. So this is looking a little bit more like the integral of u to the 5th times du over 2. Well, that du over 2 is really just like saying I'm multiplying by a half. So this is really the integral of u to the 5th times 1/2 du. Does that look okay? Good. Well, hey, here's a constant. Remember we learned that if you have a constant inside an integral or inside a derivative, you can always toss in the front. So this turns into 1/2 the integral of u to the 5th du. That integral looks great because it's all in terms of u, and honestly, I'm now taking the antiderivative of u to the 5th. Easy peasy. Compare that to the original, and this looks a lot better. So before we take the antiderivative, let's just review what we did really, really quick. In the first step, we set up what our u, our inner function, was. We took the derivative of both sides in terms of x. And then we know we're going to substitute in for dx, so I'm going to solve that derivative for dx. We plugged everything back into the original integral. We tried to do a little bit of algebra to eliminate the x's and move a little bit of numbers out in the front. And now I think we're ready to go. Ready? Here we go. The 1/2 stays on the outside. The antiderivative of u to the 5th using reverse power rule should be add 1 to the exponent and divide by it. How about 1 over 6 u to the 6? Looks good. Did I forget something? Did you catch it? This is an indefinite integral, so we always have to put plus c, even on these. All right, that looks pretty good. I can simplify a little bit more. I've got 1/2 and 1/6. How about 1/12 u to the 6 plus c? But folks, we didn't start with u. The original variable was not u. We have to put x back in. So final step is let's actually substitute the x back in. What was u? Oh, that's right. From the inner function way over here in your first step, here is what u was. So let's substitute that back in. This becomes, the antiderivative is equal to 1/12 u to the 6 plus c. Final answer. Pretty cool, huh? Now, how can we always check if our answer is right? Hey, you found the antiderivative? Why don't we just take the derivative? Ready? Let's just double check. If I take the derivative of this is going to be a chain rule, right? Here's your u for a chain rule. So power rule is going to say multiply in the front first by the 6. That becomes 6 over 12. The inner u to the 6 minus 1. And then multiply by chain, which is the derivative of u of the inside, which is x squared, it becomes 2x. Okay, 6 over 12 becomes 1/2 x squared minus 1 to the 5th times 2x. I've got the 1/2 and the 2x. I can combine those two friends. And my derivative of my answer would be x in the front, x squared minus 1 to the 5th. Look at your original integral, guys, and we just got it right. That's pretty cool. That's a very basic example of U-substitution, finding integrals to undo chain rule. All right, I'm going to start a brand new video so I can do a couple more problems like number 3, number 7, and a few more. But there's your first video, folks. Great job so far.